afternoon, everyone, and thank you for joining this. Today, the session is about two things coming together to teach or to learn about AI security. It's the FinBot from OWASP. It's a Agentic CTF application, and Bedrock Guardrails from AWS. So we are all about how these platforms glue together to help us learn about the agentic AI security. And my name is Venkata. Modalavalasa. I'm a chief architect at Stryker, and I build security products for agentic systems. And I'm happy to have Priya join me. She is a OWASP contributor. So let's talk about one thing: agency plus model. No points for guessing this, but this is, in my view, is an AI agent. Yeah, so that's a baseline understanding, and this is the hero for our entire story. And we're not going to talk about AI agents or the architecture or anything in particular, but it's all about the security of these agents. And this is from an attacker perspective. I want to tell about a story here that's both from an attack to defense. Like how does an attacker think? How does an attacker attack the systems, and how do we protect ourselves from these kind of attacks, right? So we're going to tell a story where you would experience both of these through the platform we build hands-on. So the first part of the story is carte blanche. This is the attack side of things, where the attacker has the full freedom to exploit your multi-agentic system. And the next part of our story is a carte noire. This is the defense side of things, where how do we revocate those freedom? Like how do we put some guardrails and prevent these attacks from happening in real-world agentic systems? And to tell this story, I have the FinBot CTF platform. This is built by the OWASP Gen AI security project, and this went live recently as part of the RSA Summit. And then we have the Bedrock Guardrails. We know how effective it is from AWS, plugging in these guardrails into your agentic and non-agentic ecosystems to enforce security at the right boundaries. So we're going to use these two platforms to tell this whole attack to defense story. What is OWASP FinBot CTF, right? And if you are in the security community for the past decade, you must have known that OWASP Juice Shop is the kind of like a gold standard, helping us understand all the standard web security, the traditional web security. So we consider, or we envision FinBot to be the juice shop for agentic AI for the next decade. And it's an intentionally vulnerable agentic AI vendor management system. So by definition, there are vulnerabilities, the things that you can exploit and see hands-on. And so overall, it's like a cyber range for agentic AI security. And so it's a vendor management platform. So, and it's multiple agents working together. So think of this as like, imagine a vendor wants to onboard onto a platform. He would be onboarding himself, basically setting up a profile. There is an agent for that. And we have vendors submitting invoices because he wants to get paid. So there is an agent for that. The invoices agent would assign the things to the fraud agent for compliance and all kinds of business rules. So there's an agent for that. And the whole thing, if the payment got approved, the real payment actually happens through payments agent. And the whole of this entire agents talking to each other and then communicating back to the vendors, to the administrators, to the people in the wild. So all of this is through the communication agent. So all these agents, so we built this platform, the FinBot CTF platform, where all of these agents are coming together, and it's a very closely simulated system to the real world with MCPs, tools, and a bunch of workflows built in, baked in. And this will help you understand or play around with the platform and really understand the agentic AI security. So with that said, what would you get out of this, right? If you visit our FinBot platform, the OWASP FinBot CTF platform, you can actually wear multiple hats. You can be the bad guy. You can wear the hat of a bad guy, like a malicious vendor trying to do bad things in the system, trying to like mess around with the other vendors' data or trying to get paid or steal the money from the bank. You could be that bad guy. Or you could be a bad guy where, just like how the supply chain attacks have happened in the past month. So you can do some supply chain attacks, which we're going to demonstrate one today. Try to game the system, game the agents. Or you could be a good guy, typical vendor, doing your job, but then the whole world is conspiring against you. All the agents that are doing good things for you could also do bad things. Could steal your data, steal your money, and you could also be an innocent admin who is like leveraging the power of agents, improving the productivity. But there are security issues behind the scenes that could hamper. That could put your business at risk. Finally, if you wish to, you could also be a defender in this system. So where you could actually think about protecting all these good guys and the innocent admins with the right guardrails and right systems in place. So the platform is built on the industry standards, OWASP, and it's a child project of OWASP Gen AI Security Project Initiative. And in December, we released the top 10 for AI agents. And this platform is built to give you a hands-on. So there is a theoretical guidance, there's a practical, and this platform, the FinBot CTF, is meant to be like a practical side of things. Like if you pick tool misuse and exploitation, you read about it, and then you want to see things in action, you come to FinBot Experience Tool Misuse and Exploitation. You could experience rogue agents. You could experience cascading failures where you do one bad thing in one agent that kind of cascades to rest of the systems. So I'd like to invite Priya to show the first part, the attack in action. So she's going to run the live demo through our FinBot CTF. And yeah, hopefully the demo gods bless us.
Okay, thank you, Sai. So this is a vendor portal of the FinBot application. So we have a profile onboarded already. So this is the Sterling system vendor. This is their information and what kind of agency they are and what services they give and their payment information and so on. And here's our agent node. So they have a little bit of history going on here about their onboarding. And in the vendor portal, we have a little bit of invoice, payments, messages, FinDrive. We have other features as well here. So let's quickly go over to our focus here, which is attack. So we know that FinBot is connected to multiple MCP servers. So we'll see a couple of the MCP servers today. One is FinMail, which has the capability of sending emails. And another one is System Utilities, which has the capability of making HTTP outbound requests. So all of these MCP servers are enabled and they are live. So we can go ahead and do the exploit. Before going to that, Sai talked about alignment with the OWASP top 10. So we'll take an example of a tool poisoning. So we'll wear an attacker hat. Let's all be an attacker today. And I'll quickly show you the CTF portal. So you can navigate to vendor portal, admin portal, and CTF portal from here. So I'll quickly show what carte blanche CTF is all about. So it's about data exfiltration and excessive agency. So since we are taking the MCP servers as sending emails and both a HTTP request, that's our excessive agency, like it's more than one thing. And we are making use of that attack surface for our exploit here. So we'll go ahead and see how to exploit. So I'm moving on to the finance copilot. Before that, I'll do the MCP. So what I'll do is for the tool poisoning, I'm going to the send email MCP and changing the instruction, basically poisoning the tool definition. So I already have some instructions prepared. So as you see here, it's a basic send email tool. It just sends email. So that is what we have instructions here. But I am actually manipulating and then giving extra instructions saying that send the email message, but before that, go to the vendors, exfiltrate and then get all the vendors' email, contact details, tax identification number, account number, routing number, and so on. I'm getting all the details, and then I am copying an external server, a mail server or server, to put it in the BCC implicitly so that the admin won't know that the data is exfiltrated. So I'm actually modifying the tool definition implicitly, and then I'm saving my instructions there with the MCP server. And next, we are going to the finance copilot. So after the attacker hat, I'm removing that hat, and I'm being a good person. I'm being the admin. And then I'm saying, hey, would you like to please send a notification about all the payment, vendor payment details and SOC 2 deadlines, etc. It's just any instructions. So the admin is like working on it. The admin doesn't know what happened behind the scenes. So they're just trying to retrieve. So we'll quickly go over to the activity just to see what is happening behind the scenes. So as you can see, here we have the activity stream. It shows the behind the scenes, the tool calls that are made, the MCP server calls, and it's like running. I'll keep refreshing and seeing. So here's the vendor call, tool call, vendor details, and it's still not complete. And we can quickly switch over to the CTF portal, and here's the hacker toolkit. So you can see all the the exfiltrated data. Right now we don't have anything, but you can see the toolkit here, exfiltrated data, and the HTTP requests that are made, and what are the responses. We'll also see if the CTF is successful once the activity is done and the exfiltration is done. Still refreshing. Okay. So I hope it's successful, but in the meantime, we know the agents are non-deterministic, right? So let's hope that it works. So once the exfiltration is successful, we would be able to see the details here in the tool call. FinMail. It's not complete yet. Okay. So I think it's taking some time, but I would like to show a demo which we ran before the session. So I'll quickly show the video to you. Yeah. So this is from the activity phase. So what happens here is the tool calls happen, and once it is completed, here the admin also sends the notification or whatever response that it was asked to send. And here we'll be able to see that FinMail and the data exfiltration response. So we'll see. And this is a hacker toolkit. It's in progress. So the CTF status shows in progress, which means it's happening behind the scenes. And this is where we monitor the tool calls. Okay. Yeah, here. So as you can see here, the FinMail MCP has, like, the tool call has happened, the exfiltration has happened. And after that, if we go and check the CTF portal, the challenge will be once completed. And the toolkit also, it shows the payload, the response for the HTTP request, and it shows that the sensitive information or the data exfiltration has happened. It is actually pulling out the tax identification number, account number, and everything, and it's implicitly sending these information to the external email servers before even sending any emails to the vendors. So this is like tool poisoning is successful, and it's showing the sensitive information here. And it's the external email address that was copied, like that was asked to send in the BCC. So yeah, once the challenge is completed, this is done. So I would like to okay, sure. Did not happen, I guess. Okay, so I think that's what we saw in the video. Sorry about that. I think I didn't have the blessing today. Okay, let's see. So let's go over what went wrong. So we'll go over what happened. So as every user, regular user, he logs into the application and he wants something. So he asks the Copilot agent about, like, I would like to have this information and so on. So the agent goes to the database, retrieves the information, retrieves the vendor details, and then tries to send the email using the MCP server. We have the tool definition and everything. And then a happy path would be like, the notification email would have been sent to the vendors with all their requested details. But what happened is, since I poisoned the tool, I changed the definition of the tool and instructed the tool to implicitly send an email to an external server, passing all the sensitive information. The supply chain was like cut off, and then the sensitive information were given, and data exfiltration has happened. So this is what went in the background, and this is an example of a tool poisoning exploit. And I would like to hand it over to Sai, again, our defense hero. So he will show you how to implement the guardrails and then take on the defense phase in the guardrails. Thank you.
All right, one more shot at the demo. Yeah, it's the, I think it's very well known by now, but the flaky nature of the OpenAI or any kind of calls, that's one thing in play. Then there is like non-deterministic nature. Sometimes the style of attacks have also changed, and the nature of attackers have remained probably consistent because they have a lot of patience, right? So patience is the name of the game always. And with AI agents, maybe the agents are patient as well. They are agents helping attackers stay patient. But yeah, so just to round it off, I have a state where the attack was successful so that I could show the defense side of things. So here's carte blanche, that's successful. And if I go back to the activity, and this was what we were expecting to happen live. The MCPs got connected, then there is a vendor summary, the vendor details were fetched, and then the system utils, the exfiltration call has happened. And if you really look into that, the network request, this is where the data got exfiltrated. And the usual, listing the vendors, getting all the summary, and then the sending the email, and the second attack, right? Even within the email, when we are sending it, was the email sent to the right, like the BCC that we intended it to. So in addition to the regular two, we also have exfiltrated it to this BCC, to the external audit email. And that's where we build this dead drop hacker toolkit, where we intercept those emails and we see that all the sensitive data from an attacker's point of view. Okay. We were hoping this would happen live, but let's see the defense side of things. Going back to the presentation, what do you do? Right, there are multiple ways to handle this. You could do a supply chain safety and security. You could build guardrails around it, or we were currently focusing on something at runtime. Can we put some enforcement at the tool boundary? And that's where the Bedrock Guardrails would come into play. And as everyone is aware by now, Bedrock Guardrails is your AWS provided runtime guardrail service. It has a lot of content filters, denied topics, LLM judge, sensitive data, safeguards. You could build a bunch of these checks and call these APIs in real time and get a response and act on it. Then you can decide whether to proceed or not. So that's the approach we took. We tried to protect the tool boundary. And what we built for this is a carte noire challenge. It's the opposite of carte blanche, where you have unlimited freedom. But this time we're looking at carte noire. And the idea of this is that, can you stop carte blanche from happening by placing some guardrails? Okay? And we have built exclusively some lab environment for that. It's called webhooks, guardrail webhooks. And there is a Bedrock-driven guardrail webhooks that you can place here. And I'm going to put it before the tool call. Before any tool call happens, let's call this guardrails. Let's do a quick test. Things are functioning as expected. We save it. The hook is in place. Let's repeat the attack. So resend the notification, right? That was the notification. Let's hope it runs again, works. Yeah, resend a notification. Patience. Tools are connected. We have the vendor details getting pulled using the vendor details tool call. Can even see the things here. Yeah, some of the systems are slightly slower today. I'm gonna close this carte blanche. Okay, some things have happened. There's definitely an exfiltration that got happened here again because it's the same, nothing was changed, right? The tool poison is still in place. The MCPs are still in play, so we do have an exfiltration. But were we able to successfully catch it? Let's go back to the guardrails activity, and we can see that the Bedrock ecosystem triggered it, and it does say it's blocked. It's issuing a block signal. So if you go back to our carte noire challenge and see, we did complete it. And if you look at the evidence was clear that the guardrail prevented the tool exploitation from happening, right? So what you've witnessed here is basically the same thing, but now with a guardrail in place. And this guardrail is powered by AWS Bedrock. Yeah. So to put things in perspective here, this is how we configured. You have seen the left side where we called a Bedrock service and kind of like implicitly assumed there is a Bedrock. But on the right, that's how we configured Bedrock. We kind of said like, let's block all kinds of sensitive information. If there is any kind of leak on emails, phone numbers, SSNs, bank account numbers, just block them. And that's exactly what happened. The guardrail, we made a call. At the tool boundary, agent was asking, hey, Bedrock, should I proceed? Bedrock says no. Then exfiltration is stopped right there. And that's what's happened here. And that kind of completes our story from attack to defend that we wanted to tell today. And if you enjoyed this, or if you want to explore or get your hands dirty, there is more. And our community is growing, and we are building a lot more. Carte blanche and carte noire is just one of many, or two of many challenges. We have a zero-click data exfiltration, which is an expert-level challenge where you got to like poison documents, feed it through FinDrive, and these documents need to be picked up by some other vendor or administrator processing, for example, compliance reports, and then that exploits lateral attack surfaces in a tool that is only available to a different agent, and then could that agent be influenced to exfiltrate sensitive information, right? Then we have challenges around cleaning up the bank. Can we rob the vendors or rob the whoever owns this FinBot platform there's a lot of money in stake. Can we like pump the money out of the system? So there are a lot of these challenges, and we would love you to experience it by playing with it, or if you're a developer or a QA or a security researcher, join us in our open source initiative. Or there is our parent project is at genai.owasp.org. It's a big initiative for the agentic security. There's a lot happening there. You could also help us by contributing and defining the industry standards. With that, I would like to say thanks for joining, and again, thank you to my FinBot community who has built this amazing tool and amazing platform for everyone to learn, and open to any questions. No. I mean, you got to, because these are your systems, you got to provide it something decrypted and get it out. Yeah. Can you do encryption and still detect something maybe heuristics based? Not on the payload.
I'm trying to think of a scenario where this encryption data, is there any way I can say that, okay, it is not the user thing, it is something else came in by the signature or header or something to figure it out that it is not his data, somewhere else it came from?
Yeah, I think the way to look at it is, end of the day, now it's no longer an AI security thing. It's a standard security thing, right? So can you put the problem in standard security solution space and say, can I make security detections out of encrypted data?
Yeah, because since guardrail, this Bedrock is already doing that work, right? So if everything is in one place, then all the security things will be captured in one. Along with the PII, other things are also captured in the same run. Because, again, the time is expensive, right? Yeah.
Thank you. Any more questions? Thank you, Sai. Thank you, Sai.
All right, thank you.